Hello, viewers. In this class, we're going to look at linear equation. We're going to explain the definitions of linear equations. We're going to look at the meaning of expressions and some terms associated with linear equations, and then the results of problem. This is an introduction to linear equation. Now, an equation is said to be linear if the highest power of the unknown is equals to 1. Okay, looking at the board here, we have y is equals to ax plus b. The unknown in this equation here, is x. We're asked to find x here. So the highest power of x here is 1. In any equation where the unknown is the highest power of the unknown is 1, such an equation is called a linear equations. Other name for linear equations include open sentence or simple equation. Okay, in this equation, it only has just one solution. That is why we call it linear. And besides, if different points are plotted, this is what we're going to, the kind of graph we're going to have. We're going to have a straight line graph. That's why we also call it a linear equation. Okay, here we are going to look at some terms here. In an equation of this form, the y here is a function of ax plus b. Okay, this is an equation. Why do we call it equations? Okay, equations are usually obtained from expressions. Okay, then we must know what is expressions. Expressions are just mere mathematical statements. Why equations are obtained from expressions by including this equality sign. So, for instance, this here, this ax plus b here, we can call it expression, and y on its own we can also call it expression. So by the time we put this sign here, they are no longer expression but are now transformed into the equation. So equations are formed from expressions. So expression give rise to equation. Here, as you can see here, we have a coefficient. We have a unknown. Now we have y is equals to ax plus b. The a here is called the coefficient of the unknown. In mathematics, a coefficient is a numerical number that multiply another the unknown in mathematical statements. Okay, here the b here is constant, and the y here is also constant. Though a is constant, but is acting as a coefficient. So the x here is called the unknown. Why do we call it unknown? That is, any value you are trying to find in an equation is referred to as the unknown. Okay, then we have having understood that, in order for us to understand this topic thoroughly, we will look at two aspects of numbers theory. We'll call it additive. We call it additive inverse, and the other one is called multiplicative inverse. So these two terms will enable us to do very well in trying to see how we can resolve problems involving linear equations. Now, what do we really mean by additive inverse? In a short form, the additive number of any number is usually obtained by multiplying the number by a negative 1. So the additive inverse is usually obtained by multiplying that number by minus 1. For instance, if we have 5 as a number, the additive inverse of 5 is will now become minus 5. Multiply 5 by minus 1, that will give us minus 5. So that is the additive inverse. One of the characteristics of additive inverse is that a number plus its additive must usually give us a 0. So 5 plus minus 5, it will usually give us 0. Then let's look at the meaning of multiplicative inverse. Now, let's not go into long definition. If we have 5 here, the multiplicative inverse of 5 is usually obtained by, say, using 1 to divide the number. Okay, so the multiplicative inverse of 5 is 1 over 5. So that is, you turn the number around while you make the numerator become the denominator and denominator become a numerator. This approach will be very, very important in these discussions. It will make our work easier and faster. Okay, now let's go into some operations of linear equations. Let's look at some examples of linear equation. Let's look at this. Imagine we have this example 1. Say solve for x. I'll have 3x plus 6 is equals to 21. So this is a typical example of a linear equations. Here, we are seeing 3x plus 6 is equals to 21. Here, the 3 here is called the coefficient of x. It's very important. While the x here is the unknown, we see that plus 6 and 21, they are constants. They are what? Constants. So what do we need to do here? With this, what we just explained, not quite long. Having this is 3x plus 6 is equals to 21. What we need to do here, we look at this constant here we have in equation, we have two sides. This is the right hand side and the left hand side. We look at the left hand side, look at the constant here. We have 6 plus 6. Now the next thing, having this idea of additive inverse, what you need to do is to look for the additive inverse of plus 6. And I said for you to have the additive inverse of this 6, this is plus, it becomes minus 6. So that's the first thing you do. Look at the number here, the constant on this side containing the unknown. The constant number on the side containing the unknown, you look for the additive inverse of it. Here, the next step you say add minus 6 to both sides. So once you have done with this becomes 3x 6 minus 6. Then here we have a 21 minus 6. We have done that. So the first thing you do, like I said, look at the constant number here, find the additive inverse, you add it to both sides. Always add it. So having done this, this will now reduce to 3x, 21 take away 6, that will give us 15. Then the next step here is that we're going to look at the other term we use, multiplicative inverse. The multiplicative inverse is usually associated with the coefficient of the unknown. Okay, now this is 3. Then we will look for the multiplicative inverse of 3. Here, this is 3 over 1. The multiplicative inverse of 3 over 1 will become 1 over 3. So we multiply both sides. We say multiply both sides. Multiply both sides by 1 over 3. So here we have a 1 over 3 times 3x is equals to 1 over 3 times 15. Here you see this will go with this of 3 here 1, 3 in 15, that will give us 5. So that x is equals to 5. But in some cases, the one we are used to, another way we can do, we say collect like terms. You see the same thing, but this is very good approach because it helps us to reduce so many processes. Okay, so like collect like terms, now this will move this way, and then when you get to this place, all you need to do is say divide both sides by 3, is still going to give us the same result. Now let's look at another example here. Example 2. Here, example 2. It says solve this. We have a 3 over 4 p minus 1 is equals to 11. Equals to 11. Say we should find the value of p in this situation. Okay, here what we need to do here, we'll look at this constant term here, and we'll find the additive inverse of it. So additive inverse of minus 1 is crucial here. So all we need to do is say add additive inverse of minus 1 is plus 1. We have to say add 1 to both sides. To both sides. So here we have a 3p, 3 over 4p minus 1 plus 1 is equals to 11 plus plus 1. You see, having done that, you see that this minus 1 here is completely gotten rid of. So here, this will become 3 over 4p is equals to 12. Okay, now assuming we are using the other process, say divide both sides by this, it is going to give us a very long process. But with the help of this multiplicative inverse, we will be able to do this without making a mistake. Now, this is 3 over 2, 3 over 4. Let's find the multiplicative inverse of 3 over 4. This will become 4 over 3. So you say, the next step, you say multiply both sides by 4 over 3. So you invert this. You multiply both sides by 4 over 3. So this is 4 over 3 times 3 over 4p is equals to 4 over 3 times 12. So here you can see this is, they are off, and here become p. P is equals to 3 here, 1, 3, 12 is what? 4. 4 times 4, that will give us what? 16. So this is how you use this approach, to handle a problem that of this nation. Okay. Then in our next class, we will be looking at linear equation of different form. The one that are different form from this type. Okay, but this is the general form. All you help me hit the subscribe button, and you subscribe to my YouTube channel, and also share this useful information on your social media platform. Have a nice time.